Right, we are on page 4 in our notes. But I agree. I was glad I remembered. I thought that exact same this morning, same thing this morning. Alrighty, so we are moving on to our last, which are acids, and they have a different set of rules. So acids are going to start with hydrogen. So water can be an acid in certain conditions. So you can name it as an acid, you can name it as a covalent compound, but since it just has kind of a common name, we tend to use that more. So acids are compounds that are produced by the hydrogen ion. Hydrogen plus hydrogen ion. And they are bonded to an anion, which is something negative. And when they are dissolved in water, they will ionize and produce hydrogen cations. So for us, and later on second semester, we'll do a whole unit just on acids and bases. But any compound starting with a hydrogen is going to be an acid. So acids usually only contain nonmetals, hydrogen, and either one or two more elements. We treat them as ionic compounds because when they're put into solution or into water, they are going to present that H+ ion. The higher H+ concentration, the more acidic something is. So if it's more acidic as the more hydrogen ions are, would that pH be getting larger number or smaller number? pH scale, where's your acids? Up above 7 or below 7? Below 7, exactly. So the more hydrogen ions, that means it's a stronger acid and it's going to get below 7 and move on down to 0. So there are two types of acids and each one of them has their own set of rules. So the first kind is binary acid. Bi just meaning two. So these contain hydrogen and only one other atom. So for the binary acids, you're going to be combining hydrogen with only any of the negative anions that are at the top of your ion sheet. So this is going to be hydrogen with one other atom. So that's going to be, so some room here, anything that's going to be in group 15, 16, or 17. And whenever I talk about those groups, I'm talking about, well, the group on the periodic table, but also mainly on your ion sheet, because that's what you'll be looking at to try to either name them or write the formulas. That is not every negative anion that hydrogen can combine with, but it's going to be the most common ones, which is what we try to stick with. All right, and then the other kind of acid is an oxyacid, which means it contains oxygen. So it's going to have hydrogen, oxygen, and at least one other element. So this is where you are using the bottom of your ion sheet. So for an oxyacid, you're going to be using your polyatomic ions. All right, so we'll go back up to the binary acids. A binary acid is always going to start with the prefix hydro. It's going to have the root of the element, kind of like we did whenever we were using our prefixes, and then it's going to end in ic. So if it starts with hydro, it has to end in ic. Those always go hand in hand. So if I looked and if I was given HS, I would first of all need to recognize it's a hydrogen. Recognize it's an acid because it has a hydrogen. And then since it only has one other element, then I would know it's going to follow my binary acid rules. Same thing here. HCl is an acid because it has hydrogen. It's only with one other element. So I'm going to put prefix of hydro, root for chlor, and then ic as the ending. And then obviously on all of these, you have to attach acid to it. They are all acids. All right, then if we move to our oxyacids, the rules are different. For your oxyacid, there is no hydro prefix. Gotta leave that behind. They're named completely different. Move this up a little bit. So for our oxyacids, you're going to be working off the polyatomic ion to get its name. So for an oxyacid, you're going to start with the root of the anion. And like I said, it's usually polyatomic ion. And then you're going to make some changes to it. So if your polyatomic ion ends in 8, you're going to change that to ic. If it ends in ite, you're going to change that to us. So an example of that would be nitrate. If I use the nitrate ion, that's what my acid has. Since this ends in 8, when it became an acid, it would be nitric acid. And then if we used, instead of nitrate, if we use nitrite, that's right here. You can see that NO2 is a nitrite. Since it ends in ite, we're going to change that to us, and that would become nitrous acid. So the first thing that you need to do is you need to decide that it is an acid. So when you take your test, really the first step you need to do as you work through all of the different ones is decide if it is an acid, a covalent compound, or an ionic compound. Get them separated into those 3 so you can apply the appropriate rules. All right, so all 6 of these are acids because they all start with hydrogen. So my first one, I have hydrogen and I have more than one atom with it. I have that oxygen. So that tells me that this is an oxyacid. So I'm working with my polyatomics down on the bottom. So if I find SO4, what is SO4? The name of that polyatomic ion? Sulfate. So our rule is 8 becomes ic. So this would be sulfuric or sulfic acid. Sulfuric is really the name of that, but it kind of doesn't follow the rules 100%. There's a little bit of like history behind it where they've kept it. So I would accept either one of those. If you gave me sulfic, it's obvious that you know how to apply the rules. Next one, HBr. So is that a binary or an oxy? Binary. So I'm going to start with hydro. My root for bromine would be brome. And if it starts with hydro, it has to end in ic. I'm really having trouble simply writing. Hydrobromic acid, exactly. All right, next one, H3N. Just like whenever we were doing our ionic compounds, we do not give any kind of prefix for that 3. So is this binary or oxy? Binary. So we do hydro, the root for nitrogen, and then we have it as ic. Hydronitric, I think I left the R out there, acid. All right, why don't y'all try those last 3 and then we'll flip it. Well, they would have found it, so probably would have found this. I don't know the answer to that. I feel like that they would have, something like that probably would have an acid, how it works, probably would have had to be found at first in nature, and then maybe after somebody realized that, they put together some other pressures to make some other ones. A lot of these are not real common, like I've never had to buy hydroiodic acid for. So we use the sulfurics a lot. Nitric acid is really strong. We try not to use that. Probably hydrochloric and the sulfurics or sulfus acid are probably the most common ones that we use. All right, HI, what would that be? That one sounds weird. Hydroiodic acid. H2S. Hydrosulfic, or same thing, hydrosulfuric. I would take either one of those. And for some reason, that one, like if I put it on a test or a quiz, kids miss that one all the time, that particular one. And what's my last one? Sulfurous acid. That's my ite. So sulfurous acid. All righty. So now we're going to go the other way. If I have the name, how am I going to write the formula? So the only positive ion, the only cation that you're working with is always going to be the H plus. Your second anion is going to be dependent on whether it's a binary or an oxyacid. But just like an ionic compound, overall, the compound must be balanced. So my plus must be equal to my negative. So with that being said, the only subscript added would be to hydrogen. Because hydrogen is a H plus. So if you're combining it, you're either combining it with a -1, something that's a -1, or then it gets smaller from there. But the subscript would always, if you have to add one, it would always go on the hydrogen. All right, so you kind of have to work backwards a little bit. So like nitric, I have to kind of think, if it's nitric now as an acid, what was it originally? What becomes from your polyatomic ion to your acid? Which one becomes ick? Nitrate, exactly. 8 becomes ick. So that means I started off with the nitrate, which is NO3 - 1. Remember, when you're using your polyatomic ions, all of this makes up the polyatomic ion. And all of that is equal to a -1. So this 3 down here, that 3 subscript, that does not have anything to do with the charges, or that's not part of something you are adding to the outside of the parentheses. All of that makes up that polyatomic ion. So if it's nitric now, it was originally nitrate. It's an acid, so it has to start with hydrogen. Nitrate is a -1, hydrogen is a +1, so you do not have to give the hydrogen any subscript. So the that works here, whatever polyatomic ion you're working with, if you will take its charge, so in this case, take its charge, make it positive, that would become the subscript for your hydrogen. In this case, that means that it would be a 1, and we don't ever write 1. So that's why that one did not need a hydrogen. So let's do one that does, so it'll make a little bit more sense. All right, phosphorus acid. So if it's phosphorus now, then what was it originally? Phosphate or phosphite? Phosphite, exactly. And phosphite is PO3, and all of that has a -3. So we know it starts with hydrogen because it's an acid. Hydrogen is only a +1. This phosphide is a -3. So if I take that, make it positive, that will become the subscript for my hydrogen. So it would be H3PO3. By doing that, you're evening out the charges, or you're making it neutral overall. All right, why don't y'all try those other 4? And I'm going to put down a couple of binary acids too, because there's none of those left listed. Of them. All right, what did we get for acetic acid? This is the acetate ion, and it was a -1, so that's why my hydrogen didn't need a subscript. Carbonic acid. H2CO3. Chloric acid. 3. And chlorous acid. All righty. And hydrobromic. That would be phosphoric. Yeah, if it has that hydro, then make it, you have to not worry about the, yeah. I'm just, oh, you do it to here. Sorry, I did that one. Hydrobromic, so just HBr. Have we already done phosphorus acid? Yeah. Okay. Hydrochloric acid. Just HCl. Remember, if it starts with hydro, I kind of think of them like the simpler ones. That's hydrogen just with one of these that are up here. There's only like 7 or 8 that would combine with up there. All right, so y'all have some time for practice. Everybody did I think everybody did really good on the covalent compound, so you probably don't need to worry about that. On page 9, I think that's where ionic starts, which is what we're having a quiz on over tomorrow. And then page 13 is where acids start. So see which one you think you need to work on. If you are worried about the quiz tomorrow, then work on your ionic for now and ask questions if you need to. We are going to continue to do just some review over them tomorrow and then also on Monday before the test on Tuesday. So we'll do a couple of review days.